Howdy folks, this is another episode of the LDMOS amplifier build. Right now we're going to get ready for soldering the transistor onto the copper heatsink. Wanted to show you some of the tools. We're going to need some very long nose pliers because this is going to be really hot when it comes off of the hot plate. This is the hot plate. It's sitting on the largest burner on my stove, the largest coil. That's going to get up to 225 Celsius or 440 Fahrenheit. So we have pliers for that. This is 1/32 diameter or 0.031 solder. This is just regular 6337 solder, like 0.031. And what we're going to need is about 85 millimeters of this, and the plan is to make a squiggly S kind of snake going back and forth maybe 10 or 12 times. It's going to sit in the well, and the LDMOS transistor is going to sit right on top of that. We have an IR thermometer. This is a really cheapy kind of guy. He's about $3.50, I guess. This is made by Topdon, Topdon. This is a video one with like the infrared camera, but one that has like the laser dot will do just fine. What you're going to want to do is find aluminum plate at about a half to 3/4. I have one here that's 3/4 thick. Probably a half would have been just fine. Maybe even 3/8 would have been fine, but this one's 3/4 inch thick. It's about big enough to hold the copper, so it's the 8 inches square. The important thing here is a little bit of painter's tape, and you're going to want to point your IR thermometer at the painter's tape and not at the aluminum. The reason why is the aluminum has a very low emissivity. It's something like 0.65, whereas painter tape has 0.95, 0.96 emissivity. So it's going to give you a more accurate reading if you set the emissivity on your IR thermometer to 0.95 and you also point at this painter's tape. Another possibility is a thermocouple. If you have a Fluke or X10 handy multimeter, and it's also got the Type K or Type T thermocouple, you're going to want to use Kapton tape, which is that yellow clear tape. Look it up on Google, Kapton. That's with a K. And you're going to want to put like 2 or 3 strips of Kapton and get that thermocouple to sit as tight as possible on the aluminum. Okay, going back to the setup. So what you're seeing right here is the cool down plate. It's just an extra chunk of heatsink that I have. It's sitting on a pair of chopsticks, anything just to keep it off the table, and then a pair of fans. And the fans are gonna come on. I think you hear that. And that's going to be our cool down table. Now here's the problem though. I have to relocate it from here when it's really hot to over here, and that's where these come in. You're going to want to try to grab through the screw holes in the copper plate as hard as you can, because you don't want to slip, and bring it over to the cool down plate. A few other things, some flux. We're going to put a little bit of flux on the bottom substrate of the LDMOS transistor. I don't want to take it out of the package just yet because I'm not ready for it, but the LDMOS transistor will need a little bit of flux on the footing, just a light thin coat, and again about 85 millimeters of this kind of wiggling back and forth in the trough. Let the transistor sit on top of that. Let the whole thing heat up, and eventually the transistor will just sit down in the trough. The solder will reflow, and the transistor, you'll see it will just kind of set down onto the copper. At that point, you're going to want to slide the transistor back and forth a few millimeters, a little bit of pressure, just to make sure that it completely reflows underneath the footing of the transistor. Just rock it back and forth, and then get it off of the hot plate. This whole operation, once it reflows, should only be about 60 seconds. So get it to sit, get it to reflow, and align it so that it's more or less along the center line. It is kind of important that it is centered, so I might make some center marks. And the reason for that is the input board and the output board have pads for the drain and for the gate, and I really want them to line up just perfectly. So I'm going to have to make sure that the transistor is more or less centered across the copper plate. So that's pretty much it. When I come back, I'll probably have the copper heated up and the transistor just about ready to reflow. Okay, we are currently sitting about 188 Celsius. Yeah, we're at 186, 188 Celsius. The painter's tape turns black after a little bit of while of heating it up, but we're gonna put the copper now onto the heat, and then we're gonna ramp up the heat until we get to 225 Celsius, 225 Celsius. So we're gonna need because I don't want to touch that plate right now. We're gonna need these to get it where I need it to be on the hot plate. All right, I'm going to start ramping the temperature back up slowly. This is still pretty cold, so I'm just going to do a little tiny adjustment here. You can only do that in the first couple of seconds because the copper will get hot real fast. After you use it, or after the solder melts, you're going to want to use something like this to kind of push it around. Don't use your fingers. Okay, we're at 180. And we are slowly heating up. Alright, we reached 225. I'm going to put down the IR thermometer and just start probing around with the stick. Alright, I'm already seeing it reflowing. Alright, I'm going to kill the heat because I don't need any more energy added. What I need to do is to make sure that this thing is completely reflowed. And then it sits properly. Okay, I made some marks. I'm gonna try to make sure I line up with those marks. Everything looks good. Looks like it's seated properly. Time to get this off without touching it. I'm gonna go over to the cooling area carefully. Okay, we're in the cooling area. Fans on. Just gonna let it sit there on the cooling pad until it becomes completely cool. And make sure everything's off. Looks like the alignment's good. Looks like the reflow is good.